Hi and welcome. In this video I'm going to show you how to build a game like Flappy Bird using Solar2D or Corona SDK as it was called earlier. I know, Flappy Bird, it's so 2014, but it's a great game and so many people know it. I love building games and I want to talk more about this game engine. Solar2D is free and makes it really easy to get started with game development, and specifically 2D mobile games. The game engine is cross-platform, so you can build for iOS and Android at the same time, with just one code base. But enough about that, it's time to start building the clone. First, you can go to solar2d.com to download it. You can go to Downloads, and down here you can find the binary files, if you have Windows or Mac or whatever you want. When you download it and install it, you can run it, Corona, still called Corona Simulator. And then we can create a new project, Flappy Bird. I create it in a games folder I have, like that. Then I can show in the Finder. So here I get a folder with a few files. I want to talk about this in a different part of this series. Here I have the simulator running, but it's just black for now. So I can go ahead and open the project in VS Code, my favorite editor. All of the code for this game will be in main.lua, at least for now. Just to demonstrate how simple Solar2D can be, I can add a square to the screen with just one simple line. Local bird equals display dot new rect 100 200 20 20. So it's 100 pixels from the left, 200 pixels from the top, and it's 20 by 20 pixels big. If I save this now, I can go to the simulator and you will see here a white square I just added. Before I want to do anything more, I want to do some configuration. I always use the same setup for how the screen works. So inside config.lua you will see that the screen is 320 points wide and 480. This leaves a border on the top and the bottom of the screen, and I don't want that. I want the game to fill out the whole screen. First I want to get I can just remove all of this. First I want to get aspect ratio, local aspect ratio display.pixel height divided by display.pixel width. The aspect ratio is the ratio between the width and the height of the screen. I want the screen to be 360 points wide. This could be lower and it could be higher. 360 is just what I'm used to work with. So I set this width equals 360. To get the height, I just multiply the width with aspect ratio. Width times aspect ratio, like that. And then I just need to apply this to the application config. Application equals content width equals width, height equals height, scale equals letterbox. This helps us to scale the screen. Frames per second should be set to 60. And then we can save this and everything works as it should. The last thing I want to do before I start building the game is to include a copy of a library called relayout. I already downloaded this file here, but I can leave a link in the description so you can get it yourself. So I copy relayout, just paste it here. To use it, I import it at the top here, local relayout equals require relayout. So this will import this file. This just helped me to get the position of elements on the screen and helped to get the screen size and similar. So it's very neat to have. You can just close those files. So now it's time to start building the game. First, I just want to set some variables. Layout, local, underscore W, underscore age, underscore CX, underscore CY. And then I get those values from the relayout file. Layout.cy. Here I make it easy to get the width, the height, the center of the screen vertically, and the center of the screen horizontally and vertically, of course. Then I want to do some changes to the bird. I don't want him to just be white. I want him to be yellow, just like Flappy Bird. Bird.fill 110. I just mix red and green, and that makes it yellow. And I also don't want him to be placed 200 pixels from the top. I want him to be placed on the middle of the screen. So if I save now, we should see a yellow square on the center of the screen, 100 pixels from the left. Feel free to customize the color as you want. The bird also needs a few more properties. Bird.velocity. This is the vertical speed for the bird so that he can fall and flap. Bird.gravity 0.6. This is the amount of gravity we want to add to the bird. Since the mechanics of this game is so easy, I just want to simulate physics instead of using a physics engine. So in order to move this bird, we need to call a function for every frame. And to do that, I create a new function called local function update. And in order to call this, I need to add an event listener. Runtime, add event listener, enter frame. So every time we enter a frame, we call the update function. You can test it by printing update. And you'll see that this is running. It should be calling 60 times per second. You can just remove this. But still nothing happens to the bird because we need to apply the gravity and the velocity. Bird.velocity equals bird.velocity minus bird.gravity. And apply this to the y position of the bird minus bird.velocity. If I save now, you'll see that it's falling off the screen and below. So now we can make it possible to flap so that it doesn't fall off the screen. And to do that, I need to create one more function. Local flap. We can call it touch because we need it for different things. Local function touch. Pass in an event like that. And here I want to check which phase of the touch we are on. We have different phases like begun, moved, and ended. And I want to use the begun phase. If event.phase equals begun, like that, and we say bird.velocity equals 10. And in order to call this function when we touch the screen, we need one more event listener, touch, and touch. So when we touch the screen, we call this function, and that's it. So now I can go to the simulator to test this, and when I click the screen, the bird jumps or flaps. Perfect. So now we need some pipes for this on the screen. The first thing I need is to create a new table, variables, local pipes, table is the same as a list or an array in many other languages. And I also want to keep track of if we can add pipes to the screen or not. Local can add pipe. I will explain this very soon. And I also need a function to do this. Add pipe. Local function add pipe. Inside here, the first thing I want to do is to get a random opening between the pipes. Local distance between equals math.random 100, 200. So we get the integer between 120 and 200. Then I want to get a random vertical position for the pipes. Local y position equals math.random 150 and the height of the screen minus 150. I do this so it doesn't go too far up or too far down. And when I have these two, I can first create the top pipe. Local p top equals display dot new rect. I want to place it 50 pixels outside of the right of the screen. Add the y position minus distance between divided by 2, because the anchor point for this is on the middle and not on the bottom. Minus 300 pixels, which is the height of the pipe divided by 2. I set it to 50 pixels wide, 600 pixels tall. Sorry, not pixels, it's points. And then I can set the color of this pipe to be green. Fill equals 0, 1, 0. You can also customize this if you want. And I want to set one more property, type pipe, so that when I do collision testing later, I know if it's a pipe we are crashing in. And then the last thing for this top pipe is to add it to the table we created up here. Pipes, oh, plus 1 equals p top. So here I get this pipes table, I check the length of this, and then I add 1 to it, so that this will be added to the first position inside that table. And then I can just copy this, because the bottom pipe will look similar. Just to rename this. And instead of subtracting, I want to add it like that and add 300 pixels. So now everything there should be working. But I also need a sensor to check if we are through the pipe, so we can add points to the player. I can copy this again and just rename it P sensor. Set the type to sensor, and this doesn't have to be more than 5 points wide, and I want it to be to the right of the two pipes. But if I save now, they won't be added to the screen, because we need to call the add pipe function. So inside the update, just add a comment like that, so I can separate the code a little bit. If can add pipe is larger than 100, add pipe. Sorry, add pipe. And if this integer is more than 100, we want to reset it to 0. And below here, we can just do add 1. So for every time we call this, we increment can add pipe with 1. And when it reaches 100, we call the add pipe function. Sorry, yeah, add pipe. That's correct. That's easy, but the pipes is still outside of the screen, so we can't see them. To move them, I want to use something called translate. So at the top of the screen, now top of the update function, I want to loop through all of the pipes. Like this. So now I loop through them one by one. And I want to get a local object or a local reference to the pipe. Equals pipes at that position. And to move it, I just say object translate -2 and 0. So I want to move it 2 pixels or 2 points to the left for every update, and we don't want to move it vertically. So if I now save, you will see that they start to come here, but the position of the sensor is wrong. That has to be placed on the center of the screen, and I can set the height to the height of the screen, like that, so that they're always filling out the whole screen. Okay, starting to look better. The problem now is that when the pipes go outside to the left of the screen, Corona or Solar2D is still keeping track of them, and that's not a good thing, because they will keep adding up and the game will be slower and slower, so we need to fix this. So inside here I can check if the object.x position is lower than -100. So if it's 100 pixels or points, sorry for the pixels and points mistakes all the time, but if it's 100 to the left of the screen, we want to remove them. So one more time, I get the local version of the pipe, but instead of using the same way, I say table.remove pipes and y. So I remove from the pipes table at the I position. And before I remove it from the screen, I just want to check if it's nil. If child not equal nil, then child remove self, and child equals nil. So now the object will be removed entirely once it's outside of the screen. You can test it and see that nothing crashes. Yes, looks good. So now we can do some collision testing. I do this by creating a new function. I'll just copy this too from a different project I have. Utilities, the check collision. So what this function does is to check if object 1 and object 2 intersect with each other. So this is what the whole function look like. Next, I will use this function inside the loop, inside the update function and inside the loop. So below here, I can say if check collision, pass in the object and we pass in the bird. Then we know it's a collision, but I want to check if it's a sensor or if it is a pipe. To do this, I say if object type equals sensor, then we can print score like that, small, else print die. So if it's not a sensor, we know it's a pipe, and then you die. But instead of just keep incrementing many points here, because the collision will last more than 1 frame, we need to remove the child. We can do that here. Just paste this. And then we can save and test. Just refresh. Let's see. Okay, you can see now in the console to the left that I get score, And if I crash in the pipe, it says die. Perfect. You also see that when I hit one of the sensors, they are removing themselves from the screen. So now you can just flap away. I want to do one more thing, and that is to make sure that the bird doesn't start flying until I'm ready. So I can go back to Visual Studio Code, create a new variable up here, local has started equals false. Just copy this, and then I want to wrap all of the content inside here, inside this, so that nothing starts before we have started the game. Inside the touch listener, up here I say if not has started equals true, and save. So if I now refresh the game, it will stay there until I touch, and then it starts. That's perfect. Maybe you should also check if the bird is above or below the screen. That should be fairly easy. We can just go in here and say if bird.y is greater than the height of the screen, or if bird.y is lower than 0. Then we also want to die like that and save. Die animation will be fixed later. So if I go up here, it says die, and down here it says die. So the bird is really dead now. I will add a die animation in the next part of this series. And now it's time to wrap up this part. In the next part I will do some various changes like adding graphics, adding sounds and similar. I will also make sure that we can show the player's score on the screen and keep track of this. If you want more content like this, please click like and leave a comment below if you have any suggestions. See you next time.